we're going to take a look at the hexadecimal to decimal, decimal to binary, hexadecimal to binary equivalents. So as we stated in the presentation, this is the place value for hexadecimal, just like this is the place value for decimal. You have your ones, your tens, your hundreds, and your thousands. That will never change, just like hexadecimal. So you have to remember these values. For binary, the values are 1, 2, and it just keeps doubling as it goes to the left. All right, those are the values you must remember for hex, decimal, and binary. Everyone, 16 to the power of 0 is 1, 10 to the power of 0 is 1, 2 to the power of 0 is 1. And then the hexadecimal values from 0 through 9 and A through F. So as we see the decimal value of 7824, if I told you I was going to bring this to class for you today, you would know that it was $7,824 because of the place values. The 7, we multiply it by 1,000, we get 7,000. The 8 by 100, we get 800. The 2 by 10, the place value, we get 20. And the 4 by 1, we get 4. And if we add up the values, we get a grand total of 7824. All right, so the same thing works with hexadecimal. If you look at these values right here, if we have a hexadecimal, let's say A1, is a value of 10. So 10 times 16 would give us 160 in this position, and 1 times 1 would give us a 1. So A1 would be the decimal equivalent of 161. So let's look at that. Easy to say, but let's take a look at it. So if these are our place values for hexadecimal, right? Let me just copy the whole line, and then we'll copy it down. All right. We'll just take those 3 because we're just using 2 values. Maybe if I can grab it. All right, so let's look at the place values. So if we use this chart, and then let's say that we place the values in of the one that we just said, A1, all right? So we're going to place the value of A here because it's in the second position, and here we're going to place the value of 1. So this is our hex conversion. So now we just have to multiply the values. And A in hexadecimal, if we see it right here, is a 10. So 10 times 16 is what we're going to do here. And that's going to give us 160. All right. So let me just back this up. And then over here, the value is 1 and the place value is 1. So we're simply just going to do a 1 times 1. And we're going to get the value of 1. Now, if we just add those up, the 160 and the 1, that would be our decimal equivalent. So A hexadecimal, A1, oops, that was supposed to be a 0x. A1 equals the equivalent of 161 in decimal. Okay, so all we do is plug in the value of our hexadecimal digits. It's in the first 2 places, and we just multiply up, and that's how we get the hex to decimal conversion. All right, now let's take it one step further. We're going to go from hexadecimal. In this case, we have the values of A6. So 10 times 16 is giving us our 160. And 6 times 1 is giving us our 6. So it's a decimal value. A6 in hexadecimal has a decimal value of 166. But let's say that we wanted to convert this hexadecimal to binary. All we have to do, remember we said that every hexadecimal digit equals 4 bits. These are the values of the 4 bits. So the 6 is going to be represented by these 4 bits, and then the A is going to be represented by these 4 bits. So as we said, A was 10. If you turn on the values of 10, 8, and 2, So you have 1010 represents the value of 10 in this position. And in this position, 6 is represented by a 0. We're not using the 8. We're just counting the 4 and the 2 to give us the 6. So this, the equivalent of that A6 in hexadecimal is this value in binary. So all we took is the hexadecimal value, we broke it into 4 bits, and now we're representing it in binary. So A6 in binary is 10100110. In this example, we're going to take our decimal value, convert it to binary. Look, we're using the whole binary chart up here on the top line. This is the whole binary chart. And again, it continues to the left. We just figured out what values 166 was. The 128 plus the 32 is 160, and then the 4 and the 2 is 6. So this is the binary equivalent of 166. And then if we want to break it into hexadecimal, remember every 4 bits, so we start from the right, count 4, draw a line, start, and then count 4 more and draw a line. We don't have any in this position over here. We only have these values turned on right here. So we want to see what those values are. If you add up what's turned on, we have the 8 and the 2 turned on. That would be 10. And remember, a 10 in hexadecimal is an A. And then in this position over here, we have the 4 turned on, we have the 2 turned on, so 4 and 2 is 6. So this is the hexadecimal equivalent. 0xA6 is the hexadecimal equivalent of this binary, which is the equivalent of 166 in decimal. This is a straight hex to decimal conversion, as we saw in the presentation. The values A to 7, the placeholders are 256, 16, and 1. All we do is multiply. A is 10 multiplied by 256, 2560. 2 times 16 is 32. 7 times the place value of 1 is 7. So if we add 2560 plus 32 plus 7, we get the value of 2599. So that is the conversion of A27 in hexadecimal to its decimal equivalent. So now we're going to check our value of 2599 and see if we can turn it back into A27. So what we're going to do here is we're going to turn this 2599 into its binary equivalent. And how we do that is we start with the value, we look at the binary chart, and this top line right here represents the binary chart. So if we look at this top line and all of its values, 1, 2, 4, 8, 16, again, we're doubling as we move to the left. So we're going to figure out which bits we need to turn on to add up to 2599. So we've decided we're going to use the 2048. If we subtract that, we have 551 left. We're going to use 512. If we subtract that, we have 39 left. If we use 32, we have 7 left. So we're going to turn on the 4, 2, and 1. So those values that we use, we put a 1 in the position on the second line, and we put a 0 in the position where we did not add that number. Okay, so this gives us the binary representation of the value 2599. The second line is the binary representation 1010001001111. Okay, and now if we want to turn it back into hexadecimal, again, we start from the right, we count 4 bits in, that's represented by this yellow area, and we just look and see what values are turned on in that area. We have the 4, 2, and 1 turned on because remember, every hexadecimal digit is 4 bits long. So the 4, 2, and 1 equals 7. Then we take the next 4 bits in the orange area. We put a 1, 2, 4, 8 and see what's turned on. In that area, we only have 2 turned on. And the next 4 bits in the blue area, we have the 8-bit turned on and the 2-bit turned on. 8 plus 2 is 10, but remember a 10 is represented as an A in hexadecimal. So we were able to prove that the number that we did get up here was correct because we were able to turn the 2599 back into binary, and then we converted it back to the A27, which is its hexadecimal value. So let's do one more example. This is the binary representation, and what we want to do is to turn it into hexadecimal, which we did here, and then we're going to check it to make sure we come to a correct decimal value. All right, so this value right here in binary, let me turn it on here so that we can see it. Okay, let me make this blue. All right, so this is our value up ahead, up above, broken out into groups of 4. So remember, we start from the right and we move over. So this group of 4, if we turn it into its hexadecimal value, we're looking at the 8421 to see what's turned on. We only have a 1, so in this position it's a 1. These bits, we have the 8 plus 4 plus 2, that's 1214. That would be an E in hexadecimal. And in this position, we have the 8 plus 4, which is a 12, which would be a C. So we turn the binary into its hexadecimal equivalent. So this binary value, answer, the hexadecimal is 0xCE1. Okay. So if we actually broke this now, CE1, to turn it back into decimal, let's see what we get. C is 12. The bit position for the C, for that bit position is 256. Let's look back up here and let's get our chart for the hexadecimal. All right, these are the 4 values, the first 4 values, and let's see if we can plug it in right here and see what we get. All right, so these, let me just bring this down a little bit. All right, so these are the values. We're only using these 3, the 256, the 16, and the 1. So C is 12, we're multiplying it by 256. E is 14, we're multiplying it by 16, and 1, we're multiplying it by the place value of 1. So when we add up the 3072, the 224, and the 1, we get a grand total of 3297. That is what the value of this hexadecimal number, CE1, is 3297 in decimal. And we see what it is written right here in binary. So how we would have to figure this out, if we wanted to figure out what this blue value in binary was, is we would have to get the chart for binary. Let's just insert a row up above, and then we'll figure out what that chart is. Too many. All right, so it would be 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Remember, we're just doubling as we're going. 2048. So now that we have those values filled in, all we need to figure out is where we have a 1 turned on and add those values up. So that would be right here and right here. Let me just highlight those with a different color. So those bits we're going to be adding because they have a 1 in their position. Oh, didn't keep it. All right, let me try it this way. All right, so those are the 2 bits we're adding up. These 3 bits have a 1 in their bit position, so we're going to add those 3 bits up, and then there's a 1 down here. We're going to add this bit up. So now, if we add all of those up, we should come back to the value that we had of the 3297 down here. Okay, so let's go ahead and do that and see if it works out. Let me pull up my calculator. All right, so what we have is 2048, so I'm clear, 2048 plus 1024 plus 128. Let's see what we have. 64 plus 32 plus, and then we have this 1 down here. So if we add this all together, yes, it does come back to our value of 3297, which is what we got down here. So it does prove that we did get the correct information. We got the correct hexadecimal value, and this is the binary equivalent of that hexadecimal value right there.